Okay, here we go, guys. We got factoring quadratic expressions today. So this first section here actually kind of talks about the opposite of factoring, and it's multiplying two binomials together. And we used an acronym for this a couple of years ago in Algebra 1 called FOIL. That means multiply the two first terms, outer terms, inner terms, and last terms. And that should be review, so I'm not going to spend too much time there on that. So the whole idea of factoring is it's a process of undoing the FOIL method. So we're going to jump right into this. This should be a review here. And the big question you got to ask yourself here when you're factoring is figure out what times what gets us x squared. So we could say x and x. And then what times what's going to get us 40, but then those same two numbers need to add up to 14. So what two numbers multiply to 40 that add up to 14? In this case, that's going to be 4 and then 10 right there. And then you can always go back and check your work by doing your FOIL process up here. And I'm not going to do that on every single one, but just to show you here, I'm going to go ahead and multiply these back together. X times x is x squared. X times 10 is 10x. The insides right there, 4 times x is 4x. And then the last is going to be 40. And when you combine like terms, that gets us back to the 14x plus 40. So there we go. So this is our factored form right there. That's what you're going to box up here. So most of the times here it's what multiplies to get you the last term right there, and usually it's going to be the c as far as ax squared plus bx plus c, and then what adds to the middle term. So let's try another one here. Notice that it needs to multiply what multiplies to positive 30, but then adds up to negative 11. And right then and there, that tells me I need two negative numbers here. A negative times a negative will be a positive, but then those same two numbers will add up to this negative 11. So x times x up here in the front, and then looks like we're going to have negative 6 and negative 5 right there. What multiplies to 30 and then adds to negative 11. So not too bad. Now on one like this here, when you have a negative out in front of x squared, it's a good habit to go ahead and undistribute your negatives. So I'm going to put a negative on the outside of the parentheses, and I'm going to basically go divide each of these by negative 1. And all that's going to do is flip your signs around. That's going to be x squared minus 14x, and then minus 32 right there. Okay. Now with everything here inside of the parentheses right here, we're going to factor that. We're going to keep the original negative that we had out in front of the parentheses, and then factor the remaining stuff. So what multiplies a negative 32, and then the same two numbers, I guess, add to negative 14. Now be careful. Some people are going to want to say, oh, maybe negative 8 and negative 4. Well, actually, that add up to negative 12, so that might not work there. You could try out maybe negative 16, and if you do negative 2, but you got to be kind of careful with that because that multiplied to positive 32, so you should kind of go through some of your different options. So with this case here, if it's a negative here at the end, I know one number needs to be negative and one number needs to be positive. So I know x times x needs to multiply to the front, x squared right there, and then we'll go with the 16, and then actually it'll be 2 right there. So notice here 2 plus negative 16 will add up to negative 14. That will work out there. If it was positive 14 instead, you would swap the signs around. You'd have x minus 2 and x plus 16. And yeah, once you get all that, that is the fully factored form right here. If you wanted to, you could go distribute your negative back into only one of the binomials to keep it the same, but usually I wouldn't recommend that. I just keep that negative out in front, and then you're good to go. Okay, so here we did, I guess, the FOIL process, or multiplying two binomials in reverse, so that there were no, I guess, common factors. That's what they're looking for here. So like when we started out, before we started undoing our FOIL process, there was nothing common between all of the numbers. And I think that changes here on this next page right here. So if you look in here, or not this next page, it's the next few examples. If you look here, both of those are divisible by 7. So we put a 7 on the outside. And then we're going to say that that is, I guess, n squared, and then minus And then you go divide them both by 7 right there. So it's n squared minus 3 right there. And that is all you can do to factor that one right there. Okay, B. Looks like we got 9 as a common factor, so we'll undistribute that. Basically, that's division with everything else. So you can put 1x right there, or you can just put x, and then I guess minus 2. Okay, now from there, the rest of this stuff right here, and actually I'll do it in a different color here, the rest of that stuff right there, you can actually factor into 2 separate binomials. Got to ask yourself what multiplies the negative 2 and then adds the 1. So that right there should be negative 1 actually, and then positive 2. And that should add back up to the positive 1. Now, at the beginning we factored out 9, so you need to make sure you go put 9 out in front of your parentheses for the final step right there. So it's kind of a 2-step process right there. So, and let's see what's going on here with this last one. I guess you have everything divisible by 4. And we'll have x squared. I guess, what's that, plus 2x. And then plus 3, I guess. Okay, now be careful on this one here, because this last one here, notice you're trying to figure out what multiplies to 3 and then adds to 2. And the issue here is it needs to multiply to positive 3 and then add to positive 2. So if you did like 3 and 1, that doesn't add up to 2. So that you cannot factor right there. So you actually leave your answer like this right here. Sometimes that is all you can do. The only thing you can factor is a common, factor or a common number that you can undistribute right there. So that is how you leave that final answer. So, okay. Let's move on to the different types. When your A value out here in front is not 1, there's a couple of different ways to do this. Some people do a guess and check and then FOIL back their answers to see if that works. I do this little process here called divide and slide, or I guess that's what I call it. There's a lot of other ways you can do this. You can do something called factor by grouping with these, and it's a little bit of a process to get your answer to that, but it's not terrible. But I like divide and slide the best because it's pretty quick once you do it a few times. If you've never seen this method though, it's kind of weird at first, and you might need to go check out some other videos on this here. So we're going to assume you can pick up this pretty quick. So before you do divide and slide, you must always look for a greatest common factor first. So something that's, each of these are divisible by. And then, we'll go from there. So here's the process for divide and slide. So instead of figuring out what multiplies the 3 and then adds the 7 here, we go and take these outside two numbers and we figure out what multiplies the 12, and then those two same numbers add to 7 right there. So some of y'all might be thinking that should be 3 and 4. So the way I write this, we write it as x plus 3 and x plus 4. But we don't stop there. We got to do the division part. Now you always go back and divide by whatever the a term is right there. So whatever a is, go divide by it. So we're going to divide both of these by 4. That's the division part. Alright, some of them you'll be able to simplify like this right here, 4 over 4. That reduces to 1. So that'd be x plus 1. And then if it doesn't divide, you slide the 4 out in front. So that'll be 4x and then plus 3, just like that. So you have 4x plus 3 and then times x plus 1. And then you can go and double check, okay, is 4x times x, is that the 4x squared, which it is? Or is 3 times 1, is that the 3 right there? It is. Or you can go and check, okay, is 4x times 1, which is 4x, and 3x right there, does that add to 7x? And that does. So this thing does FOIL back into your answer. So divide and slide in that case. Okay, so not a whole lot extra to say about that. Once again, if you need extra help on that method right there, if you've never seen that before, you might want to check online. I'm sure you can type in divide and slide into Google and hopefully find a couple of videos on that. If not, just let me know and I'll hook you up. So let's try the divide and slide process here for this one here. Now be careful, it's 2 times 6, which is 12, but then the same two numbers, we need to make sure they add up to negative 7 here. So as far as what multiplies to 12 and adds a negative 7, we can go negative 3 I guess, and negative 4 right there. So I guess not too different from the last one here as far as those numbers, x minus 3 and then x minus 4. Okay, but be careful, x times x is not 2x squared. That's because we got to do the divide and slide part. So we'll go back and divide by 2. And then you're going to reduce your fractions as much as possible. The second fraction reduces to x minus 2. The first one here does not reduce at all. And even if it does reduce, like for example, if that was like, I don't know, like a 9 over 6 or something, reduce it and then swing the denominator around. So I'm not sure if we see an example where you can reduce it a little bit eventually. So yeah, but there you go. 2x minus 3 and then x minus 2 there. Okay. Can you factor this thing as a product of two binomials? So looking at this here, I guess we have a 2 out in front, so we can factor that out at least. Then that's 1x and then plus 1, I guess. But then from here, as far as what multiplies to 1 and then the same two numbers add to 1, well, 1 times 1 multiplies to 1, but 1 plus 1 does not add up to 1 right there. So actually, you can't even do anything else here. So can you write it as a product of two binomials? And binomials means, you know, two sets of things inside of parentheses, like for example, like x plus 7 and then, you know, 2x plus 8 or something like that. Those are two binomials. So can you write this as a binomial? No, you cannot. This is as factored as that gets right there. So that's kind of like all the different variation you can see with your factoring. And then you have two special cases dealing with a lot of perfect square things. So this first one here is called a perfect square trinomial. So if you have something that's in this type of format, and let me just make one up here, you could do like 4x squared plus, let me make sure I get some numbers here that work out because I'm doing this on the fly here. Something I think that kind of looks like this right here. I think I did that right. Let's see, 2x and 3. So yeah. So right there, this would be a perfect square binomial here. So the whole idea is you can square root both of the ends right there. So you ask yourself, what times what gets you a squared and what times what gets you b squared? So like on this one, you could say 2x and 2x. And then what times what gets us 9? So you could say 3 and 3 right there. And then this should FOIL back into your answer here. And then you can see, okay, 3 times 2x right there is 6x, and then 2x times 3 is 6x as well. That would combine up to 12x right there. That is how you factor those quickly. Whoops, deleted too much there. So that's the little trick right there. Basically square root both of the ends. And then I like to just double check and make sure it matches here in the middle. Okay, and then if you have negatives, if you have a negative out here in front of the middle term, put it right there on that last piece right there. So using that whole idea, we can go and factor this thing here quickly. If both of the ends, if the a and c are perfect squares, then most of the times this perfect square trinomial, you just got to check and make sure the middle term still works out. So the square root of 8x squared, I would say that's 8x. So we'll put 8x and 8x. The square root of 1 is 1, so we'll put 1, 1. And then the sign here is negative, so I'll put minus 1 and minus 1. Then I'm going to just go double check. 1 times 8x is negative 8x. Negative 1 times 8x is negative 8x again. And that should combine up to the negative 16x. So we are good to go. That is how you factor it. Another way you can write this is 8x minus 1 squared. Just like that right there. And that's actually, I guess, how they write it up here. Okay. Now the other weird case is the difference of two squares. So this one here, notice you don't have a middle term right here. It's just a squared minus b squared. So the way these factor here, it's basically the square root of the front numbers, a and b. And then one is negative and one is positive. So if I was going to like do this one here, this is a difference of perfect squares right here. This is a perfect square. Negative 81 is a perfect square. You have a difference because it's a minus. So we just say what times what is negative 16x or 16x squared. We say 4x and 4x. And what times what is negative 81. Let me make that look better. That would be minus 9 and positive 9. And if you go back and FOIL, you can go and check, okay, 4x is 16x squared. 9 and negative 9 is 81. And then check this out here. In the middle, multiply those, you get negative 36x. And then notice here, if you multiply these ends here, you get positive 36x, and that would cancel out, therefore not having this middle term, or the b term. So that's how you write those. Make sure you don't write it like this here. Don't write it as like 4x minus 9 squared, because they're not the same exact binomial. Yes, they're really similar, but they have different signs. So that is how you do all of those factoring problems here. So now they kind of mix in all the different types of factorings, I guess, that we're going to see here. So they don't really tell us. So we need to just be looking out. So if I see my ends are perfect squares, usually I'm thinking, one of the things where we do the square roots. Okay, well, the square root of 25y squared, that's 5y. That's 5y, and then this is 5y as well. And then back there, that'll be minus 6, and then we'll put that as plus 6 right there. Okay, and that is actually all you do there. That's a difference of squares there. Okay, and then let's see here with this one. I guess we got to figure out what multiplies to 12 and then adds to negative 13. And there's no common factor to begin with here, so we just start with it right away. X times x gets us x squared out there in the front. So what multiplies, I guess, to positive 12 and then adds to negative 13? Don't forget about 1 in the number. So this one's negative 1 and negative 12. And that is it there on that. Negative 1 and negative 12. Okay, and that should add up to the negative 13. Okay, let's see what we got here with this one. We have x squared minus 6x plus 9. So I guess we will factor right here. It looks like it's going to be a perfect square trinomial. X squared is actually a perfect square. And then 9 is a perfect square. So that's x, and then that has to be minus 3 and then minus 3 right there. Which you can also write as x minus 3 squared. Just like that. So not too bad there on that. Alright, and then I guess they kind of get a few problems here with words here. Think about this. Can the expression m squared plus 4m plus 6, can that be factored into a product of two binomials? If so, write the factorization. If not, explain. So we need two numbers that multiply to 6 and add to 4. And I can't think of any numbers right here, so we say, no, this cannot be factored. I guess if you wanted to write out an explanation, let's say no factors of 6 that add to 4. No factors of 6 that can add to 4. So in this case here, if it's not factorable, usually we're going to write prime. And usually they don't give you a ton of examples that aren't factorable, but if you run across that on a quiz or test or something like that, prime is usually what you want to do there. Okay, sometimes they will give us a word problem here. So let's see here. A designer wants to make a rectangular logo so that the length of the logo is twice the width, x, in inches. And then she decides to enlarge the logo so that the area will be 2x squared plus 9x and then plus 10 square inches. By how many inches does she need to increase the length and the width of the original logo? Assume all measurements are in whole numbers of inches here. So I guess, okay, so here's like the original shape here. So that's, I guess, 2x by x, and then now we got to figure out, okay, what additional thing do we need to increase it by here to get this area to be 2x squared plus 9x, I guess. So I guess with this one here, we're trying to figure out, I guess really what I would do here with this, we probably need to do something with factoring. So we're going to take that 2x squared plus 9x plus 10. We're gonna factor it just to see what happens. This is one of those cases where I would do divide and slide. First, I would check and see if these are all divisible by 2, which the 9 is not. So we're gonna have to just go with divide and slide from the get-go here. What multiplies, I guess, to positive 20 and adds to 9, and I think I got 4 and 5 for that. So we'll go x plus 4. We'll go x plus 5, and we'll divide by our a value, which is 2. So that'll be x plus 2, and then 2x plus 5. Okay, and then I guess if you kind of go through here and look, one side is already 2x, and we need one side to be 2x plus 5 here, so I guess this dimension up here at the top needs to be 5, and then we'd have the entire 2x plus 5. And then this other side's already got x, so I guess we could put like a 2 right there. And then those are the extra dimensions here that we need. So she needs to increase the length, I guess, by 5, and then the width by 2, or depending on what you're calling the length and width right there. So there you go. Cool. Example 8. Is this a perfect square trinomial, yes or no? So I would look here closely at the picture, or at the trinomial here. I would go and square root it, and then do that trick, and then go see if it foils back, and then specifically check the middle term and make sure that adds up here. So we could try 2b, I guess, in this case, and then plus, or actually minus. We'll go minus 13, and then the other one will be 2b, and then minus 13 as well. So far 2b and 2b is 4b squared. And then negative 13 is positive 169. So now if you go and add up your middle terms, that'll be, and let's write it out here, 2b squared, or I'm sorry, that's 4b squared. And then look at this here, this is negative 26b right there, and I'm going to use a capital B so y'all don't get confused here. And then you add those two middle terms right there, that's also negative 26b, which some of you guys might be seeing here what's going on, and then 169 right there. So that middle term right there did not add back up to this right here. So is this a perfect square trinomial? No, because it's not going to be really even factorable. This would FOIL back into negative 52b plus 169 right there. So I would say no. So this actually is not even the correct factorization here of this. So one way you can go and kind of check without maybe foiling back your answer is think, okay, what is right there? If that's b squared, then the square root is 2. And then if this is your, second part right there, the square root of that is 13. And then remember, that's a, this is b here. And then if you do 2 times 2 times, I guess, 13 right there, that's definitely not 26 right there. So that does not work. So it's not a perfect square trinomial. It looks like a perfect square trinomial because both ends are perfect squares, but that middle thing's not going to FOIL back to what we want. All right, and then I guess this last part here, how is factoring the trinomial ax squared plus bx plus c when a is not 1 different than factoring a trinomial when a is 1? I would just say if you go and compare some of the previous examples, like example 7, well, okay, you got to multiply the a and c together, and then we do the divide and slide. When there's nothing out in front, I guess you could say that we could multiply a and c. 1 times 12 is still 12. And then if we go back and divide, we go back and divide by 1. So I'd say there is a little bit of, similarity to it. But, so how is it similar? I would say you can still do divide and slide. You're just, dividing by 0, I guess. So you could probably word that however you want there. I won't spend too much time wording that out. But then I think that is it